Okay, welcome to 3.1a. This section of our notes is the introduction to what we would call systems of equations. Now, systems of equations are an interesting topic. Systems of equations are what we would call two or more equations with two or more variables. So, this is an introduction to it. Many of us haven't seen it up to this point. Systems are what I would say look like this. Systems of equations are where we have two equations that we are going to be graphing on an actual graph here. Okay. And what's the purpose of these systems of equations? Well, systems of equations allow us to find solutions where our graphs intersect. Okay. And a lot of this can be useful in economics and in your future math classes as well. It's a very straightforward kind of subject. So if you follow along, it shouldn't be too difficult for us to do. Okay, so the first step in understanding what a system is, or how to solve systems of equations, is we have to understand what kind of graphs we're going to be ending up with. Now, there are three types. We have one where we have an intersection between two lines. This is called a one-solution equation. And normally what will happen is your solution to this equation will look like x, comma, y. Okay, and the x, y, this coordinate is where they intersect. That is the solution of the equation. If I'm looking at infinitely many solutions, what you'll notice here that is so distinct about infinite many solutions versus no solution and exactly one solution is that there is a single line. Okay, a single line. And the key to understanding what this means or how it's infinitely many solutions is that in our system we have two equations and both equations are equal is the idea. That's the key characteristic of this. Both equations are equal. Now let's consider what no solution is. You'll notice it still has two lines like one solution, but they never intersect. Okay, so no solution equation, we have what are called parallel lines. All right, parallel lines. Two lines that are parallel. What you'll find, and hopefully you'll recognize the pattern as we go along, our two equations will have the same slope, but they will have different intersects. Okay. Now, for this assignment that we will be doing, what we will be asked to do is give the terminology, consistent and independent, consistent and dependent, and inconsistent, and then we will also have to give a solution for the equation. Now, how I would suggest you write this is you can either do IMS for this one, or all real numbers, and then for this one you can do no solution or a zero line through it. Those are considered reasonable answers or solutions to your problem. Okay. Now, let's figure out how to solve these systems of equations. The first step to solving a system of equation by graphing is first to solve each equation for y. That is, let's get y alone. If I can get y alone, that means I can graph it. And we learned from our from 3.0 how to graph, how to work with slope, and how to work with an intercept, correct? It's very similar, only this time we have to do it twice. Graph both equations, find the intersection of the line. Intersection being an xy coordinate where they meet, or this point right here. Write our solution as an xy, like we've done here, and then we can check solution, okay? And I'll explain how we can check our solution in a second. So, here we go. Let's work through our steps. Solve each system by graphing. Also name each system as consistent and independent, consistent and dependent, or inconsistent. Okay, so that's the same thing as what we were talking about with our terminology. We should have an example of every single one on our notes today, so you should know what they look like. Okay, so our first step in solving these systems of equations is first solve y. We need to solve for y here. And solving for y means getting y on its own side. We need to make sure that y is not over here with the 2x, but we need to get the 2x away from y. Now, the easiest way to do this, take your equation over here, subtract the 2x away from both sides, 2x's go, and you are left with y equals negative 2x plus 1, or you can do 1 minus 2x. But what we really care about is having our number next to our slope, or next to our variable, which is our slope, and 1 is our intercept. Okay? So when I graph this, we can start with our first equation, which is this one, and then we'll go to our second equation because the y has already been solved for. So we go 1, which is our intercept, and then it's negative 2 over 1. So what we would do is we want to go up, so we want to go down to right 1. Okay, rise over run. If it's a negative 2 top, we would go down 2, and then right 1. Down 2, right 1. Down 2, right 1. And you give yourself those dots. You can follow the same pattern the other direction. And there's my line. Straight lines here. It'll help visualization. Okay. Give yourself a line here. Now your lines don't have perfect. This is just more for me. And there's our first line. Now we want to graph our second equation. As a reminder, there's an invisible negative 1 here, and there's a 1 over top, and there's a 1 on the bottom of it. We'll write our whole numbers as fractions. It's helpful in remembering what we are graphing, or at least how you rise and run. So our intercept here is 2, so I'm going to draw a point at the 2 on the y, and then we need to go down 1 and right 1. Down 1, right 1, all the way through here, and then to do the same on the opposite direction as well. Okay, give yourself a line. Like this. And there's our system of equation. Okay, now what it's asking us to do is solve the system by graphing. Solving means getting a solution. If you can remember, over here, x, y is how we wanted to have our solution. And that intersection point was what that x, y was. Okay, so for example here, they intersect at the point 1, 3, right? 1 in the x direction, 3 in y. So we want to do something similar here. We want to look at where they're intersecting. They're intersecting right there. What is that point? First, we have to know what our x coordinate is, and then we can know our y. Our x right here, as you can see, is negative 1, and our y value is 1, 2, 3. It's 3. Okay. So that is my solution right there. That is the solution to the equation. Now, that's not all that we have to do on this problem. We also have to include what the terminology was: consistent and independent. Okay, I'll write down consistent and independent. That would also be part of my answer. Okay, this is one part, this is another. Hopefully that makes sense. Okay, let's go to our next part, our next problem. We have both equations. Neither has to solve for y. That has got to be our first step. You have to solve for y. It's impossible for me to graph this without having gotten y by itself first. So I'm going to rewrite my equation over here, 2x plus y equals a negative 4, and then solve by getting y alone. The first step is to move the 2x. That's what's impeding us from having y solved for. So I'm going to subtract the 2x, similar to what we did on number 1. From both sides, I like to keep my x on the left-hand side, so I'm just going to push that negative 4 over and leave myself with a negative 2x minus 4. Okay. Our second equation, I'm going to use up my space over here probably to do it. We have y plus 2x equals 3. I want to get rid of this 2x again. Same process. Subtract your 2x, get that y alone. So it's y equals a negative 2x. This is a positive 3, so it's plus 3. Okay. Now let's graph it. Both equations have been solved for, meaning y is alone. I go to the negative 4. What I would do is say negative 2 over 1, negative 2 over 1 for both of those. Go down because it is a negative, rise over run, so negative is down. 1, 2, right 1. You can kind of see I would probably have a dot over here somewhere. So let's do the reverse. Okay, and give myself those 2 left, 1, and give ourselves that straight line. You're always going to have straight lines. If it's curving, then I've done it incorrectly. Okay, these are straight lines that we're working with. No curves, no bends, nothing like that. So as long as I have a nice straight line, I should be okay. All right, now let's look at our next one. We have a positive 3 as our y-intercept. I'm going to go right to the 3, put a dot, and then go negative 2, 1. It's down 2, right 1. Down 2, 1. Same step. Then do your reverse. Just do your opposite movement, and you should have a straight line once you've done it. Okay. Now, let's take a look at what we've done. What are we noticing about these two lines? Do they intersect? No, they don't intersect. In fact, they look very similar to what we call a no solution. Okay. So because this is a no solution problem, I would either write NS for no solution or 0 line through it to tell me that I don't have a solution. There's no solution to this equation because they never intersect. These two lines never cross, so I can't ever find that intersection point. But just like we did over here with consistent and independent, we have to put a description or a terminology for it as well. And the terminology for this one, for these parallel lines, is inconsistent. That's what I want to put on my paper. So I'm going to go over here. I'm going to write inconsistent below it. And there I am. Okay, that's my answer. All right. This is going to be your consistent and independent, and this is going to be your inconsistent graph. Now, let's push up here. We'll do 3 and 4, and then we should be done. Okay. Once again, we are looking at something here where we have to solve for y. These are a little bit more complex. They require more thought from us to be able to do. So what I want to do first is get our y alone. Always get our y alone first. I'm going to put space here on the left-hand side to do it. So first we have negative y plus 2x equals 4. I want to get that y alone. So the first thing I'm going to do is move that negative 2x over and get negative y equal to negative 2x plus 4. Okay, but if you remember from the first page, I am not looking for negative y, I'm looking for a positive y. So the easiest way for me to do this visually is to divide both sides by a negative 1. When I divide both sides by a negative 1, my negatives will cancel for me, leaving y equals, and then a negative 2 divided by a negative 1 is a positive 2x, and then a positive 4 divided by a negative 4 is negative 4. Notice, what did I divide by negative 1? Was it just the negative 2? No. It was also including the positive 4 there. Both numbers were divided by that negative 1. If I'm dividing everything on this side by a negative 1, I have to divide everything on this side by that negative 1 as well. Now that's my first equation. My second equation would be 2y equals 4x minus 8. Now, what's stopping us from having that y alone? Well, it's a 2. But this time we can't subtract the 2 off because it's 2 times y. To undo multiplication, we always have to divide. So I'm going to divide by 2. Just like I divided everything by -1 on this problem, I have to divide everything on this side by 2 as well. Okay, and I break it up into parts. I think, well, y equals, what's 4 divided by 2? That's just 2x. What's -8 divided by 2? That's just -4. And there I have both of my equations. Hopefully we've been paying attention, and we'll notice these are the same equation. Just from this already, I can tell you that our solution is going to be infinitely many solutions or all real numbers. And the reason for that is because we are only going to have one equation. I graph -4, and then I go 2x, and that's 2 over 1, or 2 over 1, whichever one you want to do. Okay, I go up 2, right 1, 2, right 1, so on and so forth. I just keep doing my dots. Okay, get myself a straight line here that I can see. And what you'll notice about this line is that if I were to go back and do, let's say I graphed this one already, and I want to try and graph this one. Well, I'm on at -4. I go up 2, I go right 1. Oh, my bad. And nothing changes about it. This is an IMS or all real numbers solution. Okay, either is acceptable as an answer. I just need to be aware of what it looks like. Okay, so here's what I would like you to think. Remember, when we have infinitely many solutions, we have to put in our terminology as well. The only difference between this is that this one's consistent and independent, whereas infinitely many solutions is consistent and dependent. So I put that down. I do consistent and dependent. That's my answer right there. Okay. Let's move on to number 4. Once again, y has to be solved for. We've got to get y alone. In order to do that, let's draw out our equation. Let's use up the space here for x plus y equals 5. I like to rewrite it. You need to move that x over. I'm going to subtract it. Both sides. My x's go. Y is equal to a negative x plus 5. My first equation. 8x plus 6y equals 36 is our other equation. Let's write it out. 8x plus 6y equals 36. First thing I want to do is I want to get rid of this 8x. Okay, we want to move far to near. So to get rid of this 8x, I got to subtract it from both sides. Minus 8x, just like that. My 8x's are gone. That leaves me with 6y equal to negative 8x plus 36. From there, I need to get rid of the 6. And just like we did prior to with 2 on our previous problem, we divided that off. I need to divide by 6 here. Okay? But remember, it's not just one thing. It's everything on this side. I can't be picky about it. Okay? Now, some of you will have a hard time knowing what negative 8 over 6 is. It is a fraction. Okay? If you end up being negative 4/3, I will show you again on how to do this on your calculator. I've done this in the past videos before. I would like you to do alpha y equals, you get the numerator denominator, you press enter on that. I want to type in negative 8 over 6 into that calculator for me. Okay, I press enter, and it's reduced it already for me. Much better than ever using your division button. We won't need it for this. I only want to have my fractions because I'm going to be using rise over run, so it's more helpful. So this is going to reduce down to negative 4/3 x, and 36 divided by 6, that should give me 6. This also works the same way if you wanted to do alpha y equals and do 36 over 6. It also reduces to 6 either way, okay? But it'll give me my fractions rather than decimals. So, this is my equation. That is my other equation, okay? I want to remind you, this is negative 1 over 1. When I graphed it, it should actually work like that. Let's start here on this one. Plus 5. And remember, it's down 1, right 1. You always want to move right with that first movement. You always want to move right. I like to go down with my top number or up based on whether or not it's negative or positive, and then right. Always right. Okay? Never left. And then we can reverse it and go back. Okay? That's our first line. Now, let's do our second line. Plus 6 is where we start from. This time it's a little bit bigger. Let's do negative 4/3. Okay? So we do negative 4, which is down 4. 1, 2, 3, 4. Right 3. 1, 2, 3. There's our intersection point. Down 4, right 3. Down 4, right 3 is over here somewhere. So I'm just going to connect the dots as I can do here. Right there. Okay. And that's my solution right there. Now I want you to understand, these problems that will be on your assignment are not meant to trick you. They're all of them are, if they intersect on a graph point, on a charted point. If they don't intersect, they've got to be parallel lines, or they have to be a singular line like this one. Okay. Otherwise, I've probably graphed the wrong division correctly. So make sure that they're intersecting on a point like this. From there, let's actually work it out. What is my solution? Remember, it's an XY solution in this case. My X is 1, 2, 3. And my Y is 1, 2. And just like the previous one, it is a consistent, just like the one was, and independent. They move independently of each other, is how I can think about it. And independent. That's my answer for that equation. Okay. Hopefully this is helpful. We're going to be continuing this a little bit more when we're using graphing calculators in the following section. I'll explain how we can actually show this, but it will require some work from us. Okay. If you have any questions as well, please ask your teacher. They should be able to help.